Hello and welcome back to the stream. And yeah, how is everyone doing? Okay, so it's another session for Python. It is time to do Python and learn and all that stuff. And for that, let me just check on some stuff. Okay, let me just check my mic. Is it working? Hello, hello, testing. Okay, the mic's working. So we're back to Python 3.130b4 documentation. Well, the latest version is Python 3.14, which is in development. I'm studying currently the 3.13 pre-release. This is the one. If I click on this once more, so you can see this is the Python 3.13 pre-release, and this is 3.130b4. Okay, so where did I study this till? It was somewhere here, right? I think so. I'm gonna have to check on this. Just give me a minute. Hello, hello. Testing. Okay, so let's start. What do we want to do here? So this is the one, flush. So I think the last time I studied this, and today I'm going to try to study this. Cursor. Wow, there's so much in this. Let me just reload this. Parser flush. What is this? Okay, this is GH1543. Okay, these are the comments. Those are just the comments about these. So we're just gonna head on towards perplexity. Yeah, perplexity. Okay, perplexity, help us out. What have we got over here? What are we supposed to do? So let me just copy this. And just paste it here. And this is the one. I didn't leave any space over here. Okay. Okay, in the last video we already covered XML parser.flush, but this is a little bit different. This is XML pull parser.flush. So use easy words, please. Okay, the xml.etree.elementary.xml pull parser .flush method is used to force the parser to process any buffered data. This means that if the parser has not received force the parser to process any buffer data. This means that if the parser has not received enough data to fully parse an element, calling flush will make it process what it has received so far. In other words, flush tells the parser to stop waiting for more data and to parse whatever it has currently buffered. This can be useful if you're parsing XML data incrementally, such as from a network socket or a file, and you want to ensure if you're parsing XML data incrementally, such as from a network socket or a file, and you want to ensure that all the parsed elements are available. Even if you haven't received the entire XML document yet. And you want to ensure that all the parsed elements are available, even if you have not received the entire XML document yet. Okay, and how do we use this in a simple code? To demonstrate how to use xml.etree.elementary.xml pull parser.flush, let's create a simple example that shows how to parse an XML string incrementally. This example will simulate receiving XML data in chunks and using the flush method to process what has been received so far. Okay, so parse an XML string incrementally. Okay, so we're going to try to parse an XML string incrementally. This example will simulate receiving XML data in chunks, okay, and using the flush method to process what has been received so far. Okay, so what we want to do first is import, we're going to apply the import statement. Import xml.etree, xml.etree element tree as et. sample XML data as a string. This is the hashtag. What we're doing here is sampling the XML data as a string. Okay, so XML data chunk 1. This is the first chunk. Okay, inverted commas and no less than root greater than, and then we have element 1. How do I zoom in on this? Just give me a minute, please. App to zoom in Visual Studio Code. Oh, I wrote Studio. It's supposed to be Studio. Alright. Appearances, zoom in control. Control plus. Ah, there we have it. Thank you so much. Okay. Oh, it's not saved. There we go. Control S does the job. So where is it? Root element value 1. Okay. Value 1 element. I think I missed the /. Now it's time for the XML data chunk 2. Okay. Inverted commas, element 2. Less than. Just a minute, I think I was supposed to add root here. No. For some reason. Okay. So root over here starting from here, and then root ends over here. Okay, so root starts over there and ends over here. Cool. So, just type the value 2 and the lesson sign and / element 2 ends over here, I think. Yes, it does. And finally, you have to end the root over here. Very nice piece of code. Beautiful, just beautiful. And now we have to create a pull parser. Create a pull parser. Okay, parser is equal to, let me just keep it neat and tidy. capital E, capital T, et.xml. Wow, gave me the suggestion automatically. So yeah, this is XML pull parser. Okay, are you using an alias? I think so, yes. Why are we using an alias? Import xml.h3.elementary as et. So, okay. et.xml pull parser. We're using the alias. Okay. Create a pull parser. And now what I want to do is write events over here, and let me just zoom in a little more. Okay, it's unsaved. No worries. And equal, no. Equal is supposed to come over here. Yeah, it is. Okay, it's correct. And then another bracket. What do we call these brackets? Why do I keep forgetting? Damn it. Dude, I think these were the small brackets. Small brackets. What? No. Versus curly brackets. Round brackets. Okay, I keep calling them small brackets. These are called round brackets. Yeah, round brackets. And these are the curly brackets. Round brackets. Okay, my apologies. I keep calling them small brackets, but they're actually the round brackets. Round brackets. Okay, so the round brackets again. And then we do this. Start, okay. I'm gonna have to ask Perplexity to explain the code because I'm not getting it. I mean, I am understanding some portion of it, but not every part of it. So I'm gonna have to have Perplexity about this. No worries. Feed the first chunk of XML data. Okay, feed the first chunk of XML data. Alright, it's feeding time. Okay. Parser.feed. And then we have XML.data. Oh no, that's wrong. That is wrong. Parser.feed. XML underscore data underscore chunk1. Okay, nice work until now. So now we fed the first chunk of XML data. Okay. Call flush to process the first chunk. And now we're going to call flush. Okay, hashtag call flush to process. Okay, I am getting the hang of it because since the last video I couldn't like grasp the flush method. Now after this program, I'm actually understanding the concept of flush. So call flush to process the first chunk. Okay, pronounced that wrong. Chunk. All right. For event, what's this? For event, comma, ELEM. What is ELEM? In parser dot read underscore events. And then we have this colon. That is a colon, right? Colon versus semicolon. Yeah, where's the picture? Where's the picture? Where's the picture? Where's the damn picture? I mean, where's the picture? Here it is. So this is a colon, the two dots, and a semicolon has a dot and this comma. So what we've applied over here is a colon. Colon. Alright, okay, read events. What are we supposed to do next? If event. What is that? Is this an equality? Or what is this? Let me just copy and paste it here. What? Is it the same? Okay, so whatever this is, I don't know if it's a comparison or it's an equality. I don't know, okay. So anyways, if event is this, if event symbol start, I'm just gonna call this symbol because I don't know if that's an event or if that's an equal sign or it's a comparison sign. I don't know. Print F start tag. Okay, start tag. And then we have these curly brackets. Curly brackets. Yes, the curly brackets. Okay. And inside the curly brackets we have elem.tag. Okay, elif event design, whatever it is, and add the colon. After adding the colon, print another statement, add the F and then the inverted commas, right? Yes. End tag. Before we were using the start tag, and now we're using the end tag. And again with the curly brackets, and again with the elem.tag tag. Okay, that is it for calling flush to process the first chunk. So now we have called the flush to process the first chunk. And the first chunk of data, XML data, was this. Here we were feeding the chunk of XML data This is where we created the pull parser. And this is the start and end. And here we've used it. This is the start and this is the end. You can see it's being highlighted. This end and this end. Okay, so what is next? Hashtag clear the element to free memory. Okay. Clear the element to free memory. ELEM dot clear. Hashtag feed the second chunk of XML data. Okay, now it's time to feed the second chunk of XML data. So I think I do remember some part of the statement. It was like parser.feed, is it? Yes, it is. And this time it's going to be XML underscore data underscore chunk2. Oh. And add the, okay, small brackets, round brackets. Was it small bracket? Round brackets. Why do I keep forgetting? I don't know. Parentheses, yeah. Here it is. I don't know. This is weird. Keep forgetting stuff. Round brackets or parentheses. Yeah. This is the curly brackets, square, and the round brackets. It's weird how fast I forgot. So yeah, the round brackets. Okay, feed the second chunk of XML data. Done. Call flush again to process the second chunk. For event, comma ELEM and parse ELEM in parser dot read underscore events and colon. Yes, I remember the name. If event and this sign, whatever this symbol is, start. I think we have to put a colon, not a semicolon. Colon over here. You know, it's like the same code again. It's being repeated for the second chunk of data. XML data. So, what was it? Yeah, print statement. F inverted commas. What do you write here? So this is the start tag. The colon again, and then the curly brackets. ELEM.tag. ELIF. Event. So this is going to be the, that was the start, this is going to be the end. Print. And here's a problem with the indentation. It's going to bring it over here. And then add a colon over here. Okay, print. Inverted commas. This is the end tag. At the colon, the curly brackets, elem.tag. Alright, cool. Clear the element to free memory. Hashtag create a comment, clear the element to free memory. elem.clear. Control S, okay. Just gonna zoom out a little bit. Wow, I didn't realize how much code that we wrote. 32 lines of code. Cool. So if I try to run this. Okay. So start tag root, start tag element1. end tag element 1. Can I zoom in on this some way? Yes, I can. Okay, so again, end tag element. Okay, then the start tag is element 2, which is this. And then the end tag is element 2. And then another end tag is the root. So first we have the root, which is start tag, then element 1, which is also start tag, and then we have element 1 over here, which is the end tag. Okay, and then element 2 is the start tag, and then element 2 over here is the end tag. And wait a minute, I think I made a mistake over here. Yes, I did. Value 2, and I was supposed to write root. I was supposed to write root over here. Oh, okay. T. How come there is a T over here? It's supposed to be root. Root over here, and then remove this. Value 2, element 2. If I run this now, it should be different. Let me just delete this and just run it again. Okay, the start tag is root, yes. And then element 1 is start tag, okay. Or element 1 is the end tag, okay. And then element 2 should be the start tag. And the end tag should be element 2. And then finally, root is a start tag? What? How come is that possible? Oh, I made another mistake. Oh no, this is too zoomed in. I'm supposed to put a forward slasher so that it knows that it's the end tag. And if I try to delete this and then run it again, yes, now it's the end tag. This root is the end tag. Okay. And now it is time for it to explain what it does. Okay, root, element 1, element 2, and root. Incrementally, okay. Import the module. We start by importing the xml.etree.elementtree module. Define XML data. We define 2 chunks of XML data as strings. The first chunk contains the opening tag and 1 element. Opening tag and 1 element. Yeah. Well, the second chunk contains another element and the closing tag. Yes, it does. Create a pull parser. We create an instance of XML pull parser, specifying that we want to capture start and end events. Create an instance, okay. Start and end event. We want to capture the start and end events. Feed data. We use the feed method. Yeah. To send the first chunk XML data to the parser. Flush and read events. We call read events. Where are these read events? Yeah, here it is. Read events. To process the buffered data, we check for start and end events, printing the tag names. Start and end events. Okay, it's printing the tag. If it's start and end tag, it's going to print those tags. Cool, pretty cool. Good stuff. After processing, we clear the elements to free up memory, repeat for second chunk, repeat the process for the second chunk of the XML data. Now we're going to ask Perplexity to explain line by line. What is this? What is this? Okay. Yeah, the line import.xml.etree.elementtree as et is a Python statement that imports the elementary module from the xml.etree xml.etree package. This line imports the element tree module. So this is the element tree module according to Perplexity. It's importing the elementary module from the xml.etree package. So it says that xml.etree is a package and assigns it an alias of et. Okay. Let's break it down. xml.etree is a package in the Python standard library that provides a simple API for parsing and creating XML data. So it's a package. provides a simple API for parsing and creating XML data. Element tree is a module within the XML.eTree package that offers a tree-based API for parsing and manipulating XML data. It offers a tree-based API for parsing and manipulating XML data. As ET, okay, so this is a module. Tree-based API. Tree-based API for parsing and manipulating XML data. So we're parsing and manipulating the XML data based on the element tree because it offers manipulation and parsing of XML data. As ET is an optional part of the import statement that assigns an alias to the imported module. Yeah, the module over here is the element tree, which has been taken out from the XML.eTree package. ET is just an alias. It assigns an alias to the imported module. In this case, it assigns the alias ET to the elementary module. Yeah, because this is the module and it's being derived. It's been taken out from the XML.eTree package. By using the alias ET, you can refer to the elementary module throughout your code using the shorter name ET. Okay, so because elementary module, this name is long, so we wanted to keep it short. So that is why it created an alias called ET. And now we're using ET instead of elementary throughout the code, instead of typing out the full path. Yeah. Which is xml.etree.elementary every time. So instead of typing out xml.etree.elementary every time, we just use the alias ET, as you can see over here, as ET. And now we're able to use ET instead of the whole path. So that is like time saving. For example, instead of writing XML data is equal to root element and then the value element root. Root is equal to xml.etree.elementary.fromString XML data. Wow, this is actually long. It is quite long. It is pretty long, to be honest. .fromString XML data. You can use the alias and write XML data is equal to inverted commas root element value element root. Root is equal to et.fromString XML data. Yeah, this is pretty time saving. It is. This is like very long. Instead of writing all that xml.etree.elementary, you can just write et because it's an alias. Using an alias makes your code more concise and easier to read, especially when working with modules that have long names or when you need to refer to the module frequently throughout your code. So it has two uses, aliases. When we have some modules that are going to be used frequently throughout your code, we can just use an alias. Or if our module has a long name, you could also use an alias instead of it. So alias is a pretty cool thing. So what we want to know next is what is this? This is my first time seeing this kind of code. Like, I just want Perplexity to explain it to us as easy as possible. The line xml underscore data underscore chunk1 is equal to inverted commas root element 1 value 1, right, and the / element 1. Did I forget the root? No, there is no root. This root starts over here and the root ends over here. An element starts here and ends here, and then element 2 starts here and then ends here, and the value 1 is in between element 1 and value 2 is in between element 2. Okay. This is a Python statement that defines a string variable. It defined a string variable, yes, okay. Containing a snippet of XML data. A snippet, right? A piece of XML data. Let's break it down to understand what it means. So what we need to remember is that it is a string variable. So this is a variable, okay, this thing. And it's not just any variable, it's a string variable because it's storing a string value inside of it. I think that is why it's called a string variable. So yeah, and it has a snippet of XML data, a piece of XML data. Breakdown of the code. Variable assignment. XML underscore data underscore chunk1 is the name of the variable. In Python, a variable is a way to store data that you can use later in your code. The The sign is the assignment operator. Okay, thankfully. Our confusion ends over here. This is the assignment operator. So if this is the assignment operator, then this should be the comparison operator. I don't know. Let's see. So the assignment operator means you're assigning the value on the right, the XML string, to the variable on the left, XML underscore data underscore chunk 1. Very nice explanation. Thank you so much for Perplexity. Like, every time you explain it so well, and I understand it so well. Thank you so much, Perplexity. So this is the assignment operator, and it's assigning the value on the right, which is the XML string. Over here, this is the XML string. Where is it? This is the XML string. It's assigning the value, which is the XML string, on the right side of the assignment operator, and it's assigning this value to the left, which is the variable. Yeah, the value on the right to the variable on the left. Very nice. String data. The value assigned to XML data chunk 1 is a string. Yeah, it is, which is enclosed in double quotes. Double quotes. Yeah, these are double quotes. In Python, strings can be enclosed in either single quotes or double quotes. Okay, so these are double quotes. The content of the string is root element 1, yeah, value element, okay. This is an XML representation of data. Okay, so this is an XML representation of data. How to represent data in the form of XML. Understanding the XML. Extensible markup language. XML is a markup language used to store and transport data. It is both human readable and machine readable. Wow, that's cool. It's a markup language used to store and transport data. Not only does it store data, but it also transports data. I don't know to where it transports data, but it does. And it can be read both by humans and machines. In this example, root is the root element of the XML document, which is over here at the root. It serves as the parent container for other elements. Okay, so this is the parent container, obviously, because it's storing other elements, right? Element 1, element 2, the value, and all that stuff. Element 1 is a child element of root. So element 1 over here is a child element of root. So that makes root the parent, right? Yeah, so this is the parent container. Element 1 is a child element. So you can see where there's a difference. Root is the parent container, whereas element 1 is a child element. It's not calling element 1 a container, it's calling element 1 a child element of root. It contains the text, which is value 1, yeah. So this value 1 is text. It's simply text, which is the data associated with this element. Yeah, the structure follows a hierarchical format where elements can contain other elements and text. Elements can contain other elements and text. I get the part that elements can contain text, which is value 1 in this case. So this element contains the text value 1. But what does it mean that, like, it says that elements can contain other elements? Okay, anyways, I don't know. Example of XML structure. Here's a visual representation of the XML structure. This is the root, this is element 1, value 1 element. Okay, very cool. The root tag opens and closes the root element. Inside the root, there is one child element, element 1, which contains the text value 1. Usage and code. In the context of the previous example, the string is used as input for the XML parser. The string is used as input for the XML parser. The parser reads this XML data, allowing you to extract information or manipulate it programmatically. Okay, summary. In summary, XML data chunk 1 is equal to root, element 1, value 1. Element 1 is simply a way to store a small piece of XML data in a Python variable so that it can be processed later in your code. Understanding this format is essential when working with XML data in Python or any other programming language. So what I want to ask is, so why doesn't the second statement start with root? The reason the second XML string, XML data chunk 2 is equal to element 2, value 2, element 2, root, does not start with root is that it is intended to be a continuation. Oh, it's continuing. So it's supposed to be a continuation of the first XML string. It is intended to be a continuation of the first XML string, which already contains the opening root tag. It's a continuation, okay. So this is the reason, people. It's a continuation. Understanding XML structure. In XML, elements are structured hierarchically, and each opening tag must have a corresponding closing tag. Here's a breakdown of the two strings. First XML chunk. XML data chunk 1 is equal to double quotes, right? Root, element 1, value 1, and element 1 ends over here. This chunk starts with root, which is the root element of the XML document. Inside the root, there is one child element, element 1, that contains the text value 1. This chunk is incomplete because it does not close the root tag. Okay, I get it now. So this chunk is not complete because it does not contain the root tag, the ending root tag. Oh, it's the close root, and yeah, it's the ending root tag. It does not have the ending root tag. The ending root tag is over here. Okay, second XML chunk, XML underscore data underscore chunk 2 is equal to double quotes, element 2, value 2, element 2 ends here, root ends over here. This chunk starts with element 2 and contains the text value 2. It ends with root, which closes the root element that was opened in the first chunk. Very nice. So root was opened over here, and now it's ending over here. That is very cool. So we can do this kind of stuff. That's cool. What's interesting is that we're starting root over here, which is the first variable over here, but we're using another variable, and we can still end the first chunk of data over here, which is in the second variable, string variable. Why this works? When you feed these two chunks to the XML parser incrementally, so we're feeding these chunks, right, to the XML parser. It processes them as a single continuous XML document. Wow, that's interesting. So although they look like they're two separate chunks, right? They're being processed by the XML parser as a continuous XML document. Continuous XML document. Here's how the complete XML structure looks when you combine both chunks. Root element 1, value 1, element 1, element 2, value 2, element 2, root. Cool. Yeah, this is actually the same thing written over here. Summary, the first chunk introduces the root element and one child element. Yes, it does. The second chunk adds another child element and closes the root element. Very nice. That's pretty clear. This approach allows you to handle large XML documents in smaller parts, which can be useful when reading from streams or files. By using the two chunks together, the parser can correctly interpret the entire XML structure, maintaining the hierarchy and relationship between the elements. That is very cool. Very cool indeed. Next, create a pull parser. What is this? What is parser? What is et dot? Why is there a dot? What is events? Is start and end? Why are there so many brackets inside another bracket? So there's a lot of questions, but perplexity answers pretty well. The answers of perplexity are very cool, very nice. Let's break down this line of code step by step. So parser is equal to et, capital E, capital T dot capital X, ml, pu, double L parser. Okay, so and then we have the RAM brackets. Events is equal to, and then again we have the RAM brackets, right? Single quotation, single quote start, and then we have the comma and the single quote end, and then the RAM bracket ends over here, which is the RAM, which are these RAM brackets inside, and these are the RAM brackets on the outside. These RAM brackets. These are the RAM brackets, right? Just don't want to mess up the names of the brackets. Yeah. Yeah, it was in the images. RAM brackets, yeah. So anyways, ET is an alias for xml.etree.elementary. Yeah, xml.etree.elementary, which was imported earlier using import xml.etree.elementary as ET. The dot is used to access the XML pull parser class. So this XML pull parser that you see over here, XML pull parser, that is actually a class. And we're accessing the XML pull parser class from the elementary module. Okay, we're accessing the XML pull parser class from the elementary module, and that module has been taken out from the xml.etree package. It's all making sense now. XML pull parser is a class provided by the elementary module in the Python standard library. It is used for parsing XML data incrementally, which means you can feed the parser with XML data in chunks instead of the entire document at once. Parser. Where's parser? Parser is a variable name that you have chosen to store an instance. Do we have a parser? Yeah, we have it. It's on the left side of the assignment operator. Assignment operator. Yeah, this sign is the assignment operator. So this parser is a variable name that you have chosen to store in an instance of the XML pull parser class. Okay, so we're storing an instance of the XML pull parser class inside the variable. To store an instance of the XML pull parser class. By creating an instance of XML pull parser, you can use its methods and attributes to parse XML data. Events is equal start end. The events parameter specifies the types of events you want the parser to capture during the parsing process. In this case, start end tells the parser to capture start and end events for each XML element. Start events are triggered when an opening tag is encountered, and end events are triggered when a closing tag is encountered. The round brackets were used to call the XML pull parser class constructor. So they're used to call the constructor? Wow. And create an instance of the class. Okay. Inside the brackets, you specify the events parameter and its value start end. Yeah, events is the parameter and its value start end. In summary, this line of code creates an instance of the XML pull parser class from the elementary module, assigns it to the variable parser, and configures the parser to capture start and end events for each XML element during the parsing process. By using XML pull parser with the specified events, you can process XML data incrementally and respond to the start and end of each element as the parsing progresses. Cool. Feed the first chunk of XML data. There a dot. What is feed? What is XML underscore data underscore chunk 1? Parser is a variable that holds an instance of the XML pull parser class. This instance is used to parse XML data incrementally. So the variable holds an instance of this class, and this instance is used to parse XML data incrementally. The dot is used to access methods or attributes of an object in Python. In this case, it is used to call the feed method of the parser object. So basically, the object of the parser object. Yeah, and the object belongs to the object that we've created is of this class. We've created an object of the XML pull parser, and then we're accessing its methods, which is the feed method in this case. You can use a dot notation to call its methods or access properties. Feed is a method of the XML pull parser class. Yes, and we're using the object to access the feed method of the XML pull parser class. This method is used to provide a chunk of XML data to the parser. Parser.feed, okay. When you call parser.feed XML data chunk 1, you are telling the parser to process the XML data contained in XML data chunk 1. The feed method allowed the parser to handle XML data incrementally, which is useful for parsing large documents or streaming data. XML data chunk 1 is a variable that contains a string representation of a portion of XML data. A string representation of a portion of XML data. In your earlier example was defined as, this is a string representation of a portion of XML data. And this is the XML data. Yeah, it's a string representation. This string represents an XML structure with a root element and one child element. It is the input that you're feeding to the parser for processing. Summary. Putting it all together, the line parser.feed XML data chunk 1 does the following. It calls the feed method on the parser object, which is an instance of XML pool parser. Yes, it is. XML pool parser is a class. It passes the XML data chunk 1 string as an argument. It's passing the XML data chunk 1 string as an argument to the feed method. So this variable, string variable, is being passed as an argument to the feed method of this object, which is actually the object of this class, right? So we're accessing the method of this class using the object. This instructs the parser to process the provided XML data chunk, allowing it to read and interpret the XML structure incrementally. This approach is particularly useful when dealing with large XML files or streams of XML data, as it allows you to handle the data in manageable pieces rather than loading everything into memory at once. Cool. This is very cool. To be honest, all this new all these new updates to Python, they're very cool and they're very interesting. Good stuff. Now, call flush to process the first chunk. Now, this line is so confusing. I've never seen anything like this before. Okay, let's break down the line of code you provided. This line is a bit more complex because it involves a loop and a method call. Here's a detailed explanation of each part. Parser, this is a variable that holds the instance of the XML pool parser class. It is used to parse the XML data that has been fed into it. Read events. Read events is a method of the XML pool parser class. Yes, and now we're using the parser instance to access that method again. So basically we're using the instance to access different methods of the XML pool parser class, and in this case we're accessing the read events method of the XML pool parser class. So the parser variable is used to parse the XML data that has been fed into it. Read events is a method of the XML pool parser class. This method processes any buffered XML data that has been fed to the parser. In this case, the data from XML data chunk 1. So it's going to process any buffered data, right, that has been fed to the parser. And in this case, the data is from XML data chunk 1. It returns an iteratable sequence of events and elements. Each event can be either a start or an end event. And ELEM represents the corresponding XML element. ELEM represents an XML element. For event ELEM in. This is a for loop in Python, which is used to iterate over a sequence. In this case, the sequence returned by parser.readEvents. Okay. And ELEM, what is ELEM? I forgot. ELEM. Where is ELEM? Yeah, XML element. Okay. The loop will unpack each tuple returned by read events into two variables, event and ELEM, which is the XML element. We'll unpack each tuple returned by read events into two variables, event and ELEM. Event This variable will hold the type of event, either start or end. ELEM, this variable will hold the corresponding XML element that the event relates to. How it works. When you call parser.readEvents, it processes the XML data that has been fed to the parser and returns a series of events and elements. The for loop iterates over each of these events, allowing you to handle them one at a time. Here's a simplified example of how this might work in practice. You have fed the parser the following XML chunk: root element 1 value and element 1. When you call parser.readEvents, it might return something like start element root at start element 1 at end element 1 at. The for loop will iterate through these tuples. On the first iteration, event will be start and ELEM will be the root element. Okay, so in the first iteration, the event is going to be the start, which is this, and the XML element, which is ELEM, will be the root element, which is the root. Okay. On the second iteration, the event will be again start, and ELEM will be the element 1 element. First is root, and then it's element 1. On the third iteration, element will be end. Yes, it will be. Sorry, it's event, not element. I was reading element. It's actually event. My apologies. This is event, okay, not element. So on the third iteration, the event will be end, and the ELEM will be the element 1. So this is the event, and this is the ELEM, which is the XML element. Summary. In summary, the line for event, ELEM, and parse.readEvents is a loop that allows you to process each event and its corresponding XML element returned by the readEvents method of the XML build parser. Returned by the readEvents method. So we can process all the events and all the XML elements returned by the readEvents method. So whatever readEvents is going to return, we can process all the events and XML elements. That allows you to process each event and its corresponding XML element returned by the readEvents method. Event and element returned by the readEvents method. So the event and XML elements are going to be returned by the readEvents method. Okay. This is a common pattern in Python for handling sequences of data, and it allows you to react to each part of the XML structure as it is parsed. If you're new to Python, this kind of loop might seem a bit complex, but it is a powerful way to work with data in an efficient, readable manner. That is cool. Even if it's complex, it's very interesting. So now let's go to the next line. If event is... Explain this. Okay, this is a conditional statement in Python. Let's break it down to understand the purpose and functionality. If this is a keyword in Python used to create a conditional statement, it allows you to execute a block of code only if a certain condition is true. Event is a variable. Event is a variable that holds the type of event returned by the readEvents method. Okay, it is a variable that holds the type of event returned by the readEvents method. So this is going to read the event, this method, and this variable, if it is the event, it's going to hold the what's the event? Is it start or is it the end? It's going to hold the type of event returned by the readEvent. So this readEvent, it's going to return the event, and then this variable event is going to hold that event, whatever kind of event that is. In the context of XML parsing, event can either be start, indicating the start of an XML element, or end, indicating the end of an XML element. This is the equality operator. Finally, this is the equality operator. Before, somewhere here, we were using the assignment operator. If you remember this, I just need to find it. The assignment operator. Assignment operator, look for it. It's supposed to be somewhere here. This is it. This is the, if it's a single equal sign, it's going to be the assignment operator. Assignment operator. But if it's a double equal sign, Here it is. This is the equality operator. It checks whether the value on the left is equal to the value on the right. So that is why we call it an equality. It checks if it's the value on the left is equal to the value on the right. Okay. And the value on the left is the event, and the value on the right is start. So if the event is a start type of event, right? So it's going to be executed. This is going to be executed. This print statement. Start. This is a string literal, representing the type of event that indicates the beginning of an XML element. How it works. When you use the if statement in this way, you're asking the program to check whether the current event is a start event. If the condition is true, that is, if event is equal to start is true, then the block of code that follows means what comes after this. Follows, that means this statement, the next statement. So then the block of code that follows, the if statement, will be executed. Example context. Here's how it might look in the context of the loop we discussed earlier. For event, ELEM and parse.read events. If event equals to start, is equal to start. If event is equal to start, reconnection success. Hello, testing. Okay, sort of lost my connection over here. Hope everything's okay. Hello, testing. Okay. So what's going to happen next? The block of code that follows the if statement will be executed. Here's how it might look, right? In this example, the loop iterates over events returned by parser.read events. So this loop is going to iterate over events returned by the parser.read events method. For each event, right? So for each event, it checks if the event type is start. So for each event, it's going to check if the event type is start. If it is, if the condition is true, it executes the code inside the block, which is this. In this case, printing the tag name of the element. So if the event is a start event, so it's going to print the tag name of the element, which is this. ELEM.tag. You know what ELEM is. That is the XML element .tag. So this is going to print the tag name of the element. So this is cool. The line if event is equal to start is a way to determine whether the current event being processed is the start of an XML element. Start of an XML element. If it is, the code that follows will execute, allowing you to handle the start of that element appropriately. This is a common pattern in programming for controlling the flow of execution based on specific conditions. Now we're going to move on to this line. Now explain this. The line ELF event is equal to end is part of a conditional statement in Python. So remember, this is a conditional statement based on Perplexity's answer, specifically an extension of the if statement we discussed earlier. Let's break down this line to understand its components and functionality. ELIF stands for else if. It is used to check an additional condition. If the previous if condition was false, you can have multiple else if ELIF statements following an if statement to value different conditions. Event is a variable that holds the type of event returned by the read events method of the XML pool parser class. Yes. It holds the type of event returned by the read events method. Event can either be start or end. This is the equality operator in Python, which checks whether the value on the left event is equal to the value on the right end. This is a string literal representing the type of event that indicates the end of an XML element. It's a string literal. How it works. When you use the ELIF statement, you're asking the program to check whether the current event is an end event, but only if the previous if condition was false, which is checking for a start event. So if the previous was false, this is going to run. If the condition is true for this second statement, which is the ELIF, then the block of code that follows the ELIF statement will be executed. Here's how it looks in the context of the loop we discussed earlier. For event, ELEM and parse.read events, if event is equal to start, print f start tag elem.tag. ELIF event is equal to end, which is string literal, print f and tag elem.tag tag. it's going to print the tag name of the element. Yeah, printing the tag name of the element. The loop iterates over events, which is this. It iterates over events returned by the parser.readEvents. For each event, it first checks if the event type is start. If it is, it executes the code to handle start of the element, printing the tag name. If the event type is not start, it then checks if it is end using the elif statement. If this condition is true, it executes the code inside the elif block, printing the tag name of the element that has just ended. For summary, the line elif statement is equal to end allows you to handle the case where the current event being processed is the end, where the current event being processed is the end of an XML element. The current, you need to focus on this, where the current event being processed is the end of an XML element. This is the part of the broader conditional structure that enables your program to respond differently depending on whether it encounters the start or end of an XML element. This pattern is common in programming for managing different scenarios based on specific conditions. And finally, after this, it's all the same. It's going to repeat itself. We've already done parser.feed before, and then it's going to do this again. Now finally explain this. The line elem.clear is a method call that is used to free up memory by clearing the contents of an XML element. Let's break down this line to understand its purpose and functionality. Components breakdown. elem is a variable that... What? It's a variable? What? How could it be a variable? Yeah, it is. It is. Okay. It is. elem is a variable that represents the current XML element being processed. It is obtained from the readEvents method, which is this. It is obtained from the readEvents method. Of the XML parser class. Each elem is an instance of the element class. Each elem is an instance of the element class. Element class? Where is that element class? Is this some sort of new class? I don't see it. Does anyone see the element class? I don't know. Okay, which represents an XML element in the parse document. Clear is a method of the element class. Element class, where is this? I see an element tree, I see an eTree, XML, I don't see the element. Is it referring to the element tree? I don't know, it just says element. Anyways, clear is a method of the element class in the XML.eTree.elementary module. This method is used to remove all child elements and text from the current element, elem, effectively resetting it to an empty state. Okay, it's basically going to send it to an empty state. The primary purpose of calling elem.clear is to free up memory. When you parse XML documents, especially large ones, or when processing data incrementally, the elements you create can consume a significant amount of memory. By clearing elements that you no longer need, you can reduce memory usage and improve performance. Here's how it might look in the context of the loop we discussed earlier. Yeah, it's the same code for event, elem, which is the XML element, and parser.readEvents. If event is equal to start, and then the colon, print f start tag, colon, element, elem.tag. elif event is equal to end. Else if the event is equal to end, print the end tag, the name of the end tag. Whatever is the name of the element. And then clear the element of free memory, elem.clear. In this example, the loop iterates over events returned by parser.readEvents. For each start event, it prints the tag name of the element. Yeah. For each end event, it prints the tag name of the element, and then calls elem.clear to remove all child elements and text from elem. By doing this, you ensure that memory is freed up for the next elements being processed, which is especially important in scenarios where you are parsing large XML documents or streams. Summary: the line helium.clear is a memory management technique that helps to keep your program efficient by clearing out XML elements that are no longer needed. This practice is particularly useful when working with large datasets or when parsing XML incrementally, as it helps to prevent excessive memory usage and potential performance issues. Cool, 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 cool. So this is it. This is it. So this is a very cool. This is very cool. Pull parser. Very cool. This is so cool. Understood it very well. Okay, this is very cool. Alright, so the next one is this. So today I've studied it till here. xml.etree.elementary.xml pull parser.flush. This is till where I studied it today. Should I do this? Should I do the next one? I don't know. Okay, here we go. So let's do this one as well. xml.parsers.expat .xml deferral enabled. Now let's move on to this one. Okay, let's see what Perplexity has to say about this. The get reparse deferral method. Deferral enabled method. Get reparse deferral enabled method is part of the xml.parsers.expat module in Python. xml.parsers.expat. xml.parsers.expat. What about xml parser? Where did that go? Which provides a low-level interface to the expat XML parser. Expat XML parser. This method is used to check whether the XML parser is currently deferring reparsing of elements. Let's break down the components of this method. xml.parsers.expat. This is a module in the Python standard library that provides a fast XML parser based on the expat library. So this provides an XML parser based on the expat library. It offers a simple API for parsing XML data. XML parser, yeah, this is it. XML parser is an instance of the XML parser class. Instance of the XML parser class. XML parser. Okay, so this XML parser is an instance of the XML parser class from the xml.parsers.expat module. Okay, so this is an instance. XML parser class. This is the XML parser class, the original. It represents the XML parser that is being used to parse the XML data. Get reparse deferral enabled. This is a method of the XML parser class. It checks whether the XML parser is currently deferring reparsing of elements. Reparsing is a feature that allows the parser to revisit and reparse elements if necessary, such as when resolving entity references or handling external entities. How to use get reparse deferral method. To use this method, you need to create an instance of the XML parser class from the xml.parsers.expat module. Import xml.parsers.expat. And then we have to create an instance of the XML parser class. Here we're creating an instance. Okay, we've created the instance, and then what are we supposed to do? Then you can call the get reparse deferral method enabled method on the parser object to check if reparsing is currently enabled. Okay, so is reparse deferred is equal to parser. Okay, so we have to call this method on the parser object, which is this. Yeah, we've created the object of this class, XML parser, and now we're calling this method on the object. The get reparse deferral method enabled method returns a Boolean value, true if reparsing is currently enabled, false if reparsing is not enabled. Example use case. One possible use case for get reparse deferral enabled is when you want to ensure that the parser has finished parsing the entire XML document before performing some additional processing or validation. By checking if reparsing is enabled, you can determine if the parser has encountered any elements that may need to be revisited and reparsed later. However, it is important to note that the xml.parsers.expat module is a low-level interface to the expat XML parser, and it may not be necessary to use this method in most cases. The higher-level xml.etree.elementary module, which we discussed earlier, provides a simpler and more user-friendly API for parsing XML data in Python. What is meant by deferral in this? In the context of the XML.parsers.expat module deferral, refers to a mechanism introduced in expat version 2.6.0 to manage how the parser handles reparsing of XML elements. Here's a detailed explanation on the provided search results. What is deferral? Reparse deferral. This mechanism delays the reparsing of unfinished tokens elements until a sufficient amount of input data has been received by the parser. This is done to prevent performance issues, particularly denial of service attacks that could occur due to excessive parsing time when dealing with large XML tokens. Okay, so it delays the reparsing of unfinished tokens until a sufficient amount of input data has been received. So until some sufficient amount of data has been received, it's going to delay the reparsing of unfinished elements. Why is deferral important? Performance security. Without deferral, the parser might attempt to reparse large tokens immediately, which could lead to quadratic runtime complexity. This means that the time taken to parse could grow rapidly with the size of the input, potentially leading to performance degradation or denial of service. Okay, immediate feedback. By enabling deferral, the parser may not call registered handler functions immediately after new input is pushed. This can be a trade-off between immediate feedback and performance, especially when processing large XML documents. How to control deferral, enabling and disabling. You can control the deferral behavior using the set reparse deferral enable method. Calling set reparse deferral enabled false disables reparse deferral, allowing the parser to immediately handle reparsing of elements. Calling set reparse deferral enabled true re-enables deferral. Security implications. Disabling deferral can have security consequences that it may expose the parser to performance issues if large tokens are encountered. Therefore, it is essential to understand these implications before changing the deferral setting. Summary. In summary, deferral in this context refers to the practice of delaying reparsing of XML elements to enhance performance and prevent potential denial of service attacks. This mechanism allows the parser to handle large inputs more efficiently by waiting for sufficient data before attempting to reparse unfinished tokens. The ability to enable or disable this feature gives developers control over the parser's behavior, but it also requires careful consideration of the associated security risks. Alright, cool. So, how can we use it? Simple code. To demonstrate how to use the get reparse deferral enabled method from the XML.parsers.expat module. Yeah, so what we need to remember here continuously that Perplexity is telling us is that XML.parsers.expat is a module. And over here you can see the XML parser, the small wordings. It said that XML parser is an instance, right? You can see it over here. There's the answer is somewhere over here. Yeah, over here you can see XML parser, which is the small XML parser. This XML parser is an instance of the XML parser class. You can see the XML parser classes over here, the capital letters. So this is just an instance. It represents the XML parser that is being used to parse the XML data. So this is just an instance. Okay, so how do we use this method from the XML.parsers.expat module? We'll create a simple example that shows how to set up an XML parser, check the reparse deferral status, and then modify it. Import XML.parsers.expat. Okay. Import parsers.expat. Create a new XML parser. Hashtag create a new XML parser. Parser. Okay, XML.parsers.expat. Dot parser create. So now we've created a new XML parser. Okay, let me just see. So Perplexity said that xml.parser.xpath is a module, right? And now we're accessing this method, parser.create. And we're storing all this in this variable, parser. Check the current reparse deferral status. So now we have to hashtag now just give it a comment. Check the current reparse deferral status. Okay, initial status is equal to parser. Okay, so now we created another variable, initial status, and then we're checking the current reparse deferral status. Is it enabled or is it disabled? So we created a variable initial status is equal to parser dot get reparse deferral enabled. Okay, parser. And now you can see that this is the variable that we used over here, and this is the same variable. And now we're using that to access the get reparse deferral enabled. I think there's something related to creating instance object like the one we did before in the previous program. Something related to objects and instances again, I think so. And then we're using a print statement initial reparse deferral enabled, and then we have the curly brackets initial underscore status. Okay, initial underscore status. Okay, initial reparse deferral enabled. And now what we have to do is enable reparse deferral. Enable reparse deferral parser dot set reparse, and now we're using the same parser variable parser. Okay, dot set reparse deferral enable. Okay, true. Now we're just enabling the reparse deferral. Okay, now print reparse deferral enabled. Am I using single quotation? Single quotes? Yeah. I'm just gonna use double quotes, so we don't have any sort of complexities. Reparse deferral enabled. Okay. So now we've set the set reparse deferral enabled. We've set it to true. We've enabled reparse deferral. We've enabled it. Check the status again. Okay, hashtag check the status again. Status, now create another variable, status underscore after enable. So now we've enabled it. What's the status after enabling it? Parser dot, I think we're gonna use the same method again, get, yeah. Get reparse deferral enabled. Yep, it's the same thing again. Now I think we're gonna use a print statement again, yes. We're basically trying to check the status of the deferral method again. Okay, so reparse deferral enabled. Reparse enabled. And we're gonna use the curly brackets again, I think. Yeah, status. Now we're using the variable status underscore after underscore enable. Enable. Okay, this is the variable you can see over here. We created this over here, and now we're using it in this print statement. Okay, disable reparse deferral. And now we're going to try to disable it. Disable reparse deferral. The parser dot set reparse deferral enabled. We're setting it true. Now, I think this time we're going to set it to false. I think so, because we're disabling it, right? So we got to set it to false. That's what my common sense says. Yes. And now another print statement. What is this F? I mean, we're not using F. I've used F everywhere. Let me just see. I used F and then check the current status, reparse referral status. Yeah. And then there's no S and F in enabling it. And then there's an F in to check the status again. And then there's no S and F in disabling it. So no need for F. Although I'm going to ask Perplexity what this means. So disable reparse deferral. Yeah, reparse deferral disabled. Disabled, okay. Hashtag. Check the status again. Wow, we're going to have to check the status again. Okay, so parser dot. No. Status underscore check underscore after. No, status after disable. Simple. Status after disable. Okay. Yeah, so parser dot get reparse deferral enabled. Check the status again. You know, I think I'm making a mistake somewhere. Okay. Check the status again. Yes, I am making mistakes somewhere. To check the current reparse deferral status, it's empty. Enable it, it's true. Check the status again, it's empty. And then we're disabling it, says set to false, and now we're gonna have to check the status again. So it's supposed to be empty, right? Yeah. Okay, so now we're gonna use a print statement. Check the status again after disabling it. And now we're gonna use F. Reparse deferral enabled. Reparse deferral enabled. And then these curly brackets, I forgot the colon. Curly brackets. Status underscore after. It's supposed to be disabled because last time we were disabling it. Status after disable. Yeah. Status again. Now example XML data for demonstration purposes. Okay. Example XML data for a demonstration purposes. XML underscore data equal to root. Right. Just add a small lesson bracket and then root. Yeah, and then this is going to be the element value / element / root. Yeah, first we started with the root and we started with the element and closed the element with the value, and then we've ended the element and the root. Okay. So now we've set the example data. This is the example XML data. Okay. Now what we have to do, okay, hashtag, which is the comment, parse the XML data. XML data. This is just to show usage, actual parsing is not affected by deferral. Oh, it's a single line comment. Okay. Not affected by deferral. Okay. So parser dot parse XML underscore data. And now we're parsing the XML data. Yeah, we're using the same parser variable to access the parse method. And now we're passing the XML data into it. Okay. Note in a real world scenario, you would also set up handlers for start and end events. Oh yeah, I forgot about the start and end events and the handlers. Okay. Explanation of the code. Import the module. We start by importing the xml.parsers.xpath module, which is over here. Yeah, xml.parsers.xpath. Create a parser. We create a new instance of the XML parser using xml.parsers.xpath.parser create. Yeah, here we're setting up an instance. I knew it. We're creating an object, we're creating an instance. So we're creating a new instance and then store, and I think this is the variable that we're using, the object. Check initial status. We call getReparseDeferral enabled. Yeah, next we're calling this method on the object, which is parser. You can call it an instance or an object, whatever. So we're calling this method on this object, on this instance. Okay. And this storing in this. To check whether reparse deferral is enabled initially and print the result. We're going to check if it is enabled or disabled. And then enable reparse deferral. We enable reparse deferral by calling start reparse deferral enabled true and print a message indicating that it has been enabled. Parser.set reparse deferral enabled true. Okay. Yeah, and then we're going to put reparse deferral enabled set to true. Okay. Check the status again. We call getReparseDeferral enabled again to confirm that reparse deferral is now enabled. Check the status again. Status after enable. Parser.getReparseDeferral enabled. Yes, reparse deferral enabled. Status after enable. Okay. Disable reparse deferral. Check. Disable reparse deferral. We disable reparse deferral by calling set reparse deferral enabled false and print a message indicating that it has been disabled. Check the status again. We call getReparseDeferral enabled once more to confirm that reparse deferral is now enabled. We disabled it and then we're again checking the status again. Enabled. Example XML data. We provide a simple XML string to demonstrate parsing, although the actual parsing behavior is not affected by the reparse deferral settings. Important note, event handlers. In a real-world scenario, you would typically set up event handlers to process XML start and end events using parser.start element handler and parser.end element handler. This example focuses on demonstrating the use of the reparse deferral methods. Performance considerations. Be cautious when enabling or disabling reparse deferral, as it can have implications for performance and security, especially when parsing large XML documents. This example should give you a basic understanding of how to use getReparseDeferral enabled and setReparseDeferral enabled in a simple get and set in a simple Python program. Why is there an F in the print statement? Some of them. The F in front of the string literals in the print statement is called an F string. Format is string literals. It was introduced in Python 3.6 and provides a concise way to embed expressions. Oh, I think this is the expression. It's used for embedding expressions inside string literals. Here's an example from the code. Print F double quotes initial reparse deferral enabled colon. curly brackets, initials underscore status curly brackets, ends, double quotes, and then we have the round brackets end. In this case, initial status is an expression that will be evaluated, and its value will be inserted into the string in that position. The main advantages of using f-strings are readability. F-strings make the code more readable and easier to understand, as you can directly insert variables and expressions into the string without having to use string concatenation or the format method. Simplicity. F-strings are more concise and require less typing compared to other string formatting methods. Flexibility. You can include any valid Python expression inside the curly braces of an f-string, allowing for more complex formatting. And for manipulation of values. Here are a few more examples of f-strings. Alice, okay, age is equal to 25, print. My name is name, and I am 8 years old. Wow, this is cool. So this name is going to be over here, this 25 is going to come right here. The result is 2 decimal places, okay. Display only 2 decimal places, alright. Allows you to easily insert variables, values, and expressions into string literals, making your code more readable and concise. So we can insert more values, variables, and expressions into the string literals, making the code more readable and concise. This is cool. Python is just cool. Beautiful. Okay. And now we have to understand the code one by one. In this, what is XML? What is parsers? What is expat? And why have we used the dot? In the statement import xml.parsers.expat, the components can be understood as follows. XML. Let me just zoom in on this. This is XML. This is a top-level package in Python's standard library. So this is a top-level package that provides support for XML processing. It contains various modules for handling XML data, including parsing, creating, and manipulating XML documents. So this is a top-level package. It contains various modules for handling XML data. So it includes parsing, creating, and manipulating XML documents, etc. Parsers. So next is the XML.parsers. Parsers, this is a sub-package. So this is the top-level package, and parsers is the sub-package within the XML package. It contains modules that provide different methods. This sub-package also contains modules that provide different methods for parsing XML data. The parsers sub-package includes various parsing techniques such as DOM, SAX, and the expat parser. Wow, this is cool. And finally, the expat. This refers to the specific module within the parsers subpackage. Okay. This refers to the specific module within the parsers subpackage. So this is inside the parsers subpackage, and then we're taking out of this. Okay. That provides a Python interface to the expat XML parser. Expat is it provides a Python interface. Okay. To the expat XML parser. Expat is a fast, non-validating XML parser written in C. Known for its efficiency and performance, especially with large XML files. The expat parser is widely used in various applications and libraries due to speed and flexibility. The dot is used in Python to access submodules or attributes within a package. In this case, it indicates that parsers, which is this, is a submodule of the XML package. Yes. And expat is a submodule of parsers. Yes, expat is a submodule of parsers. This hierarchical structure allows for organized access to different functionalities provided by the XML processing library. Summary. Putting it all together, import xml.parsers.expat imports the expat XML parser module. It imports the expat XML parser module from the xml.parsers subpackage. Yeah, it imports the expat XML parser module from the xml.parsers subpackage. This module allows you to parse XML data efficiently using the expat parser, which is particularly useful For handling large XML files, the dot notation is used to navigate through the package hierarchy, clearly indicating the relationship between the XML parsers and expat components. Okay, I just want to take a bit of a break. Okay, let us continue. So we've done this. Now explain this one by one, each word. Let's break down the line parser is equal to xml.parsers dot xpad.parser create step by step. Is it xml.parser? Or is it xml.parsers? I think I might have made a mistake. XML.parsers, this is the same. Also, if we run this, I forgot to show the output, of course. Initial reparse deferral enabled. So first, it's returning true. So this is the first statement. And then it prints this, reparse deferral enabled. And then we're going to check the status again. It is still enabled. And then we're going to disable it. And then we're going to print reparse deferral disabled. Okay. And then we're going to check the status again, and it's going to return false. Yeah, status after disable. Because that's an expression. Because we're using F. Okay. Alright. Where is it? XML. This refers to the XML package in Python's standard library, which provides support for XML processing. This is the package. Parsers is a subpackage within the XML package that contains modules for parsing XML data using different techniques. Okay, such as DOMs, SAX, and XPAT. XPAT is a module within the parsers subpackage. It's a module. Within parser subpackage that provides a Python interface to the XPAT XML parser. XPAT is a fast, non-validating XML parser written in C, known for its efficiency and performance, especially with large XML files. Parser create. Yeah, this is it. Parser create. Okay. Parser create, here it is a function provided by the XPAT module. It's a function provided by the XPAT module. It's a function provided by this XPAT module. This is cool. It's giving me the information about it. XPAT is a module. Parsers is also a module. XML is also a module. So all of these are modules. DOM, SAX, and etree. Now parser, it's a module. It is the Python interface to XML parsers. It contains the XPAT, which is the Python wrapper for James Clark's XPAT parser with namespace support. And this is XPAT. It's the module. It is the interface to the XPAT non-validating XPAT XML parser. This is parse create, which is a function. So parser create is a function provided by the XPAT module. It is used to create an instance of the XPAT XML parser. Instance of the XPAT XML. When you call parser create, it initializes a new XML parser object with default settings. Now finally we're on the parser, which is this. Parser is a variable name that you have chosen to store the instance of the XPAT XML parser created by parser create. So we're storing the instance of this XPAT XML parser inside the variable parser. So we're basically working with the object, or you can call it an instance. Okay, so this variable parser is going to store the instance of the expat XML parser created by parser create. By assigning the result of parser create to parser, you can set result parser create to parser. You can use this variable to interact with the parser and perform XML parsing operations. Putting it all together, the line parser is equal to xml.parsers.expat.parser create does the following. It imports the necessary components from the XML package hierarchy. To access the expat XML parser module, it creates a new instance of the expat XML parser using the parser create function provided by the expat module. It assigns the newly created parser instance to the variable parser, allowing you to use this variable to interact with the parser throughout your code. By creating a parser instance using parser create, you can then set up event handlers, configure parser options, and start parsing XML data using the expat parser. This is a common starting point when working with the xml.parsers.expat module in Python for efficient XML parsing, especially for large or streaming XML data. Okay, very good. And now it is time for this one. Explain this. Let's break down the line initial status underscore status is equal to parser dot get reparse deferral enabled. Initial status is a variable name that you have chosen to store the result of calling the get reparse deferral enabled method on the parser object. So we're calling this method on the parser object, and then we're storing the result in this variable named as initial underscore status. The dot is used to access methods or attributes of an object in Python. In this case, it is used to call the get reparse deferral enabled method of the parser object. So in this case, we're using the dot to call the get reparse deferral enabled method of the parser object. Yeah. Parser is a variable that holds the instance. And now we're talking about parser. So parser is a variable that holds the instance of the expat XML parser. It holds the instance. So we've got to remember this. It holds the instance of the expat XML parser created earlier using xml.parsers.expat.parser create. Get reparse deferral enabled is a method of the expat XML parser. It is used to check whether the parser is currently deferring reparsing of elements. Reparse deferral is a mechanism introduced in expat version 2.6.0 to manage how the parser handles reparsing of XML elements. It helps prevent performance issues and denial of service attacks when parsing large XML documents. The assignment operator, which is this, is used to store the result of calling get reparse deferral enabled into the initial status variable. So it's going to store the result of calling this method into the initial status variable. So whatever result we're going to get from this after calling this method on this object, on this instance, the result is going to be stored in the variable initial status. How it works: when you call parser.getReparseDeferral enabled method, the expat XML parser checks whether reparse deferral is currently enabled. The result, either true or false, is then stored in the initial status variable. This allows you to capture the initial state of the reparse deferral setting before potentially modifying it later in your code. By storing the initial status, you can compare it with the modified status to see if any changes have been made. For example, you might want to temporarily disable reparse deferral for certain parsing operations, and then restore the original setting. Storing the initial status helps you keep track of the default behavior. In summary, initial status is equal to parser.getReparseDeferral enabled retrieves the current reparse deferral status of the expat XML parser and stores it in the initial status variable for later user comparison. That's cool. And now we're going to study this line. Okay, let's break down the print f double quotes initial reparser from enabled colon curly brackets initial underscore status curly bracket finishes, double quotes are closed, and the round brackets are closed as well. Print is a built-in Python function that outputs text to the console, or standard output. It can take one or more arguments and displays them as a string. F. The F before the opening quotation mark indicates that this is an F string, formatted string literal. F string allows you to embed expressions into string literals, which makes it easy to create strings that include variable values. Initial reparse deferral enabled initial status. This is the string that will be printed. It contains both static text and a placeholder for a variable. The text initial reparse deferral enabled is a static string that will be printed exactly as it is. The part initial status is a placeholder that will be replaced with the value of the initial status variable when the string is created. Initial status. This variable holds the result of the call to parser.getReparseDeferral enabled, which indicates whether reparse deferral is currently enabled, true or false. How it works. When this line of code is executed, the following happens. The F string is evaluated and the value of initial status is inserted into the string at the position of the placeholder initial status. If initial status is true, the output will be initial reparse deferral enabled true. If initial status is false, the output will be initial reparse deferral enabled false. Summary. In summary, the line print f double quotes initial reparse deferral enabled colon curly brackets initial underscore status curly brackets closed double quotes closed round brackets closed round brackets. Print a message to the console that indicates whether reparse deferral is currently enabled in the XML parser. The use of an F string makes it easy to include the value of the initial status variable directly in the output, enhancing readability and conciseness. This is a common practice in Python for generating informative output messages. That is pretty informative. And now we're going to ask Perplexity to explain this as well. Let's break down the line parser.setReparseDeferral enabled true. Parser is the variable that holds the instance of the expat XML parser. So this variable is holding the instance of the expat XML parser. That was created earlier using xml.parsers.expat.parser_create. The dot is used to access methods or attributes of an object in Python. In this case, it is used to call the setReparseDeferral method of the parser object. SetReparseDeferral enabled is a method of the expat XML parser. So this is a method of the expat XML parser. It is used to enable or disable reparse deferral for the parser. So this is a method of the expat XML parser. So we've created an object, right? An instance. So the parser is the variable that is going to hold the instance of the expat XML parser. So we've created an instance of the expat XML parser, and then we're storing it in the variable parser. And we created this instance of the expat XML parser using this method, parser_create. Yeah, and the whole line is xml.parsers.expat.parser_create. Alright, I get it. Reparse deferral is a mechanism introduced in XPath version 0.6.0 to manage how the parser handles reparsing of XML elements. It helps prevent performance issues and denial of service attacks when parsing large XML documents. True. The argument passed to set reparse deferral enabled is true. So this is an argument that is being passed to this method. This value enables reparse deferral for the XML parser. How it works. When you call parser.set reparse deferral enable true, you're instructing the expat XML parser to enable reparse deferral. This means that the parser will delay reparsing of unfinished tokens, elements, until a sufficient amount of input data has been received. This is done to prevent performance issues, particularly denial of service attacks that could occur due to excessive parsing time when dealing with large XML tokens. So this is going to delay reparsing. It's basically going to delay, right? It's delaying the reparsing of tokens. It's not going to immediately reparse. It's going to delay the reparsing. By enabling reparse deferral, the parser may not call registered handler functions immediately after new input is pushed. This can be a trade-off between immediate feedback and performance, especially when processing large XML documents. It is important to note that enabling reparse deferral can have security implications as it may expose the parser to performance issues if large tokens are encountered. Therefore, it is essential to understand these implications before changing the deferral setting. In summary, parser.set reparse deferral enabled true enables reparse deferral for the expat XML parser, which can help improve performance when parsing large XML documents, requires careful consideration of potential security risks. Let's break down the line print reparse deferral enabled. Print is a built-in Python function that outputs text to the console or standard output. It can take one or more arguments and displays them as a string. Reparse deferral enabled. This is a string literal enclosed in double quotes. It contains the text that you want to print to the console. The string is static, meaning it doesn't change and simply conveys a message indicating that reparse deferral has been successfully enabled. How it works. When this line of code is executed, the following happens. The print function outputs the string reparse deferral enabled to the console. Purpose. The purpose of this line is to provide feedback to the user or developer indicating that the reparse deferral feature has been enabled successfully. This is useful for debugging or logging purposes, as it confirms that the previous command, parser.set reparse deferral enabled true, was executed, and that the parser is now set to defer reparsing of elements. Summary. In summary, the line print reparse deferral enable simply prints a confirmation message to the console informing the user that reparse deferral has been enabled for the expat XML parser. This kind of feedback is helpful for understanding the flow of the program and ensuring that the desired configurations have been applied correctly. Okay, I just want to take a bit of a break. Okay, let's break down the line status after enables equal to parser.get reparse deferral enabled step by step, which is this line, I think. Yes, status after enables equal to parser.get reparse deferral enabled. Alright, this is status after enable. This is a variable name that you have chosen to store the result of the method call. The method call is obviously this, right? Get reparse deferral enabled. We're calling this method using this instance, and then we're using the dot. So yeah, so we're calling this method, and we're using this variable, which is actually an instance of that thing that Perplexity told us about. Yeah, this is an instance, I forgot. Yeah, the expat XML parser, this is an instance of that, I think. I might be wrong, because I don't remember the specific words. I think it was the XML expat parser. So yeah, this is the instance, and we're using this instance to call the method, and whatever result we're getting, we're storing it in this variable. So this is the variable name that I chosen to store the result method call. It is intended to capture the state of the reparse deferral setting after you've enabled it. Yeah. Okay, so after storing the result, the dot is used to access methods or attributes of an object in Python. In this case, it is used to call the get reparse deferral enabled method of the parser object. Yeah, so you know this is the instance or object, whatever you call it. And then we're calling this method, and then we're storing the result in the status after enable variable. Okay, parser is a variable that holds the instance of the expat XML parser. Okay, I was right. So this parser is an object, an instance, whatever you call it. What it is doing is that it is a variable that holds the instance. Okay, it holds the instance, it holds the object of the expat XML parser that was created earlier using XML.parser that expat.parser create. This instance is used to parse XML data and manage its configuration, including reparse deferral settings. Okay, this instance, this object, whatever you call it, we created this using the XML.parsers that expat.parser create. Get reparse deferral enabled. This is a method of the expat XML parser. Okay, it checks whether the parser is currently deferring reparsing of elements. When called, it returns a Boolean value, true, if reparse deferral is enabled, and false if it is not. So it returns a Boolean value. That's what we know for now. This method returns a Boolean value. The assignment operator, which is a single, this is a single symbol, okay? If there were two of these, it would have been a different symbol. But since it's one, it's the assignment operator used to store the result of calling get reparse deferral enable into the variable status after enable. How it works, when you call parse.get reparse deferral enabled, so when we call this method using the object, the expat XML parser checks the current state of the reparse deferral setting. The result, either true or false, is then stored in the status after enabled variable. This allows you to capture the state of the reparse deferral setting after you've enabled it with the previous command. Parser.set reparse deferral enabled true, which is this. We set it previously, we set it to true, and now we're checking the status and storing the result in this variable, and then we're going to print the result. This allows you to capture, okay, by storing the status, you can later compare it with the initial status, store it in initial status. But currently, it's status after enable. Before we were using the variable initial status, and now we're using the variable status after enabled. Alright, we can compare the values if we want. By storing the status, you can later compare it with the initial status stored in initial status, okay. To confirm that the setting has changed as expected. In summary, the line status after enabled is equal to parser that get reparse deferral enabled. Retrieves the current state of the reparse deferral setting of the expat XML parser after enabling it and stores this value in the status after enabled variable. This is useful for verifying that the parser's configuration has been updated correctly. Okay. And now we're going to understand this line as well. Print. Let's break down the line print. After reparse deferral enabled, curly brackets, status after enable, curly brackets, double quotes, and round brackets. Print is a built-in Python function that outputs text to the console, or a standard output. It can take one or more arguments and displays them as a string. F. The F before the opening quotation mark indicates that this is an F string, formatted string literal. F string allows you to embed expressions inside string literals, which makes it easy to create strings that include variable values. Reparse deferral enabled, status after enable. Yeah. This is an expression. We've embedded an expression inside the string literal, and we've formed an F string, a formatted string literal. This is the string that will be printed. It contains both static text and a placeholder for a variable. The text reparse deferral enabled is a static string that will be printed exactly as it is. The part status after enable is a placeholder that will be replaced with the value of the status after enable variable when the string is created. So this is going to be replaced with the value, with the original value of the variable. Status after enable. This variable holds the result of the call to the parser.get reparse deferral enabled after you have enabled reparse deferral. It indicates whether reparse deferral is currently enabled true or disabled false. How it works. When this line of code is executed, the following happens. The F string is evaluated, and the value status after enabled is inserted into the string at the position of the placeholder, status after enable. If status after enable is true, the output will be reparse deferral enabled true. If status after enable is false, the output will be reparse deferral enabled false. Purpose. The purpose of this line is to print a message to the console that indicates whether reparse deferral is currently enabled in the XML parser after you've explicitly enabled it. The use of an F string, and it makes it easy to include the value of the status after enabled variable directly in the output, enhancing readability and conciseness. This message serves as a confirmation that the reparse deferral setting has been updated successfully and can be helpful for debugging or logging purposes. Okay. So we've already done this line parser.set reparse deferral enabled true, and then we've done this print statement, and we've done this as well. And now it's the same thing again. Besides, before it was true, now it's going to be false, and the reparse deferral is going to be disabled. And now we're going to check the status again. We're just changing the name of the variable, which is status after disable. You can see over here. And this is the same code. This is the same code, parser.get reparse deferral enabled. It's going to check the status, and whatever, if it's true, if it's enabled, it's going to return true, right? And if it's not enabled, if it's disabled, it's going to return false. So this is the same statements like we did above, right? So look. Okay, I'm just going to delete this, and I'm just going to play this. So you can see first what we did was enable. First we were checking the status, right? If it was enabled or not. So it said it was enabled, so it returned true, and then printed this statement. And then we checked the status again, and reparse deferral enabled true. True. Okay. And then we checked the status again, and it was still true. So that is why it returned true again. After that, we disabled it, so the result was supposed to be false, right? So this statement runs and says it's disabled. And now we're going to check the status, so it's obviously going to be false. Yeah. So whatever Boolean value it is, it's going to show the Boolean value over here. You see, what I mean to say is basically is that, look, when we try to disable it over here, we've changed the value to false, and then we try to print the statement reparse deferral disabled. So it prints reparse deferral disabled, right? And now we're just going to check the status. We're going to call this get reparse deferral enabled method. We're going to call this method. It's going to check the status. It's going to store the result in this variable. Now we know that we have set it to false, right? So it's supposed to return false because we've disabled it. We've set it to false. We've disabled it. So the answer is supposed to be false again. So when we call this method, it's going to check whether it's true or false, whether it's enabled or disabled. So you can see that false is going to be stored over here, status after disable. And then it's going to show it in our print statement. So you can see it's false. It's not enabled. It's disabled. So that is it. And finally, we want to understand this. We've already done this. We created a variable. We understood about this in our previous code, if you remember. This is an XML data. This is XML data, right? This is the root. This is the element, and in between the element is the value. Here we're ending the element tag, and here we're ending the root tag. And then you know what parser is. This parser is the same as, this is the object. This is the parser of the expat XML parser. We created an object of the expat XML parser, and then using this object we're calling its method parse XML data. I mean just parse. We're calling the method parse, and then we're passing the variable XML data into it so that we can parse the XML data. Whatever data is inside this, whatever this is the data inside this variable, it's going to parse this data. So now we're going to ask explain all this now. Okay, so yeah, this is a comment, I know. This line defines a variable named XML data, okay, and assigns it to a string that contains one piece of XML. The XML string represents a simple structure, root element, child element, containing the text content. Okay, XML structure is well formed, etc., etc. It has a single root element and properly nested child elements. Okay, this is the comment. Okay, parser, yeah, this is what we want to study. This line calls a parse method on the parser object, passing the XML data string as an argument. So now we can see over here that it's calling the parse method, right, using the parser object of the expat XML parser. And then we're passing the XML data variable. This variable we created over here, and we stored some XML data inside it, and now we're passing that variable as an argument into this method. Get it? It's pretty simple. We're passing the XML data variable, okay? It says passing the XML data string. Well, this variable, XML data, it contains a string inside it. So you can call it a string if you want. So whatever we're passing this variable, the string, as an argument into the parse method over here. Okay. And finally, the parse method is a function provided by the expat XML parser that processes the provided XML string. So this parse method is also a function of the expat XML parser, and that is why we created an object of expat XML parser named parser. And then we were using that object to access different methods and functions of the expat XML parser. When this method is called, the parser reads the XML data, triggering any registered event handlers for stored elements, character data, and other XML constructs. When parser.parse XML data is executed, the expat XML parser processes the XML data string, identifies the root element as the root of the XML structure, recognizes the element as the child of root. With the text content value, we had set up event handlers, for example, to handle certain and end events of elements. Those handlers will be triggered as the parser encounters each element in the XML. The purpose of this code snippet is to demonstrate how to define a small piece of XML data and how to use the expat parser to parse that data. And how to use the expat parser to parse that data? Yeah. Well, the example is simple and it illustrates the basic usage of the parser and how to work with XML strings in Python. In summary, the code snippet defines a small XML structure as a string, and then uses the expat XML parser to parse that string. The comments provide context and clarify that the parsing operation of the demonstration of use is not directly affected by the earlier configuration of root parse deferral. This is a common practice when working with XML data in Python, especially when using libraries like xml.parser.expat. So to end the video over here, let me just highlight this. So in this video, I studied xml.parsers.expat.xmlparser.getReparseDeferral enabled. I'm ending the video over here. Remember this, please. I'm ending the video over here. xml.parsers.expat.xmlparser.getReparseDeferral enabled. I've studied it over here till here. I've studied it till this over here. You can see it's highlighted. I'm ending the video over here. I've studied it till here. I'm ending the video over here. That is it for today. Thank you for watching. Thank you for watching the video, and wishing you lots of positivity, wishing you lots of good luck, and wishing you lots of good health. Thank you so much.